Our eyes, the windows to the world, can be tricked. Optical illusions, those captivating visual riddles, demonstrate the fascinating discrepancy between reality and perception. They remind us that our brains, while remarkably adept at processing visual information, can be fooled. This essay delves into the captivating world of optical illusions, exploring their mechanisms and what they reveal about the intricacies of the human brain. Optical illusions, simply put, are visual experiences that deceive our perception of reality. They play tricks on our brains, making us see things that aren't really there or perceive things differently from how they actually are. They involve images that are perceived differently from their objective physical reality. This means that what we see doesn't always match up with the actual properties of the objects or scenes we're looking at. Some illusions make us see things that aren't there, while others distort the appearance of size, shape, or motion. For instance, a static image might appear to be moving, or a straight line might look curved. One famous example is the cafe wall illusion, where perfectly straight horizontal lines appear slanted due to the contrasting black and white squares surrounding them. This illusion demonstrates how our visual system can be misled by the arrangement of patterns and colors. Another well-known illusion is the rotating snakes, where stationary concentric circles appear to be in perpetual motion. This effect is created by the specific arrangement of colors and shapes, tricking our brains into perceiving movement. These illusions highlight the brain's tendency to interpret visual information based on context and prior experience. Our brains use shortcuts and past knowledge to make sense of what we see, but sometimes these shortcuts lead to fascinating errors in perception. Optical illusions remind us that our perception of reality is not always accurate and can be influenced by various factors. Optical illusions arise from the complex interplay between our eyes, brain, and the physical world. These illusions can be fascinating and sometimes even mind-boggling as they reveal the intricacies of our visual system. Our eyes capture light reflected from objects and send signals to the brain, which then decodes these signals to form images. This process is incredibly fast and efficient, allowing us to navigate our environment seamlessly. The brain processes this information to construct our visual perception, piecing together various elements like color, shape, and motion to create a coherent picture of the world around us. Illusions exploit the brain's shortcuts and assumptions in processing visual information. These shortcuts are usually helpful, but they can sometimes lead us astray, creating visual experiences that don't match reality. For instance, our brains are wired to perceive depth and distance based on cues like perspective, shading, and relative size. These cues help us judge how far away objects are and how they relate to each other in space. Illusions that manipulate these cues, such as the Ponzo illusion with converging lines, can trick us into perceiving objects as larger or smaller than they actually are. This happens because our brain interprets the converging lines as a sign of depth, altering our perception. These visual tricks highlight the brain's incredible ability to interpret complex visual information, but also its susceptibility to being deceived. Understanding how illusions work can give us deeper insights into the workings of our own minds. Section 4, delving deeper. Types of optical illusions. Optical illusions are fascinating phenomena that trick our brains into seeing things that aren't really there or seeing them differently than they actually are. Optical illusions are broadly classified into three categories: literal illusions, physiological illusions, and cognitive illusions. Each category offers a unique way in which our perception can be deceived. Literal illusions, like the rabbit-duck illusion, create images that can be interpreted in multiple ways. These illusions play with our ability to switch between different interpretations of the same visual input. Physiological illusions, such as the Hermann grid, are thought to arise from the overstimulation of certain visual neurons. This overstimulation can cause us to see things like dark spots at the intersections of a white grid on a black background. Cognitive illusions, the most common type, involve higher-level brain processing. These illusions are deeply rooted in the way our brains interpret and make sense of the world around us. These illusions exploit our expectations, assumptions, and knowledge about the world. They often reveal how our brains use shortcuts to process complex information quickly. The Ames room illusion, where people appear to shrink or grow as they move across a distorted room, is a classic example of a cognitive illusion. This illusion demonstrates how our perception of size and space can be manipulated by altering the shape of the room. Section 5. Windows to the mind. What illusions reveal about the brain? Optical illusions provide invaluable insights into the workings of the human brain. They highlight the constructive nature of perception, demonstrating that our brains actively interpret sensory information rather than passively recording it. By studying how illusions trick the brain, neuroscientists can map the neural pathways involved in visual processing and identify the brain regions responsible for specific perceptual functions. For instance, research on motion illusions has shed light on the neural mechanisms underlying motion perception in the brain. Section 6 conclusion: the enduring allure of illusions. Optical illusions, with their captivating ability to deceive our senses, continue to fascinate and intrigue us. They serve as a constant reminder of the subjective nature of perception and the remarkable processing power of the human brain. Beyond their entertainment value, optical illusions provide a valuable tool for neuroscientists to unravel the complexities of visual perception and gain a deeper understanding of the brain's inner workings.